Hello, sir.
Sir, is my screen visible,
sir?
sir?
Not
No,
visible.
sir. Not visible.
Share కొట్టిన entire screen ఇది ఉంటుంది సార్. Okay. Now it's visible, sir.
Okay, sir. Shall we start, sir, or shall we wait for a while?
We will start, sir. So, dear participants, good afternoon to all, and welcome to final session of our STTP. It's my pleasure to introduce today's speaker, Mr. N. Balakrishna Garu. Mr. N. Balakrishna Garu received his MTech degree from Sestra University, Tanjavur, Tamil Nadu in 2010. He did his MTech EEE from JNT Hyderabad. He is currently pursuing PhD in Annamalai University, Tamil Nadu. His research is in the broad area of controllers for fast charging, DC to DC converters, fast charging of EVs and EV charging stations. His focus is on mathematical modeling, formulation and analytical solution of problems in implementing control strategies for fast acting DC to DC converters. He has made significant work in his selected research area. He is engaged in industrial consultancy activities for various industries and organizations, and also got expertise training from Bosch Rexroth on industrial automation. So he is a active member in Department of EEE. Okay. On behalf of EEE Department faculty and students, once again, thank you very much, sir, for accepting our invitation to access today's resource person. It's time to hand over the session to today's resource person, Mr. N. Balakrishna Garu. Sir, please continue, sir.
Thank you, Dr. Ravindra, sir, for your elaborate intro. So first, I think I hope my screen is visible to you.
Yes, sir. Everything is fine.
Okay, fine. So today we have a discussion on Internet of Things and applications, various advanced applications, what we can design in Internet of Things. In that, so let the agenda of our today's session goes like this. If time permits, I can add some more experiments to this session to control different electrical equipment using IoTs. So first I will go with introduction to IoT and applications of IoT, various advanced applications, and we will. I try to complete that the first two parts. It's a boring part which I will try to complete in 30 minutes, and most of the time we will utilize it on hands-on session. So under hands-on session, I would like to go through the Blink IoT 2.0 app. And I try to work with Arduino IDE, and I try to write coding for some small programs, and also I try to show how we can design or how we can create widgets in the phone, and from which we can control the IoT devices and all. And also I try to perform some experiments on this. Yeah. So this what is IoT? IoT, we know that IoT is Internet of Things. It's a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers. Okay. So we can connect IoT to any devices. Say it may be a chair, say it may be a table, or say it may be an animal. So we can make or we can connect the devices to the internet, and we can make them as smart. So on overall IoT is like that. And if you want to tell in a one line, IoT is nothing but what? It's a combination of one sensor device, one control, which will form into a device as a smart, and all these things connected to internet forms into Internet of Things. So these are all some crucial IoT characteristics. The first and foremost thing is connectivity. We know that connectivity is the main thing for IoT, which we make use of the existing internet as connectivity here. So things in the sense, say it may be, as I told you earlier, things may be table, chair, animal, etc., etc. So even the so the things which we don't have seen the life, also we can create them, we can connect to the internet, and we can make them as smart. Data is one thing, so data handling is one thing in IoT. Communication is one thing, and intelligence, that means we are making them as a smart, and action and ecosystem, these are all some crucial IoT characteristics that we can see here. So advantages, advantages, there are a lot of advantages here. um, Say it may be, for example, if you take industry 4.0, industry 4.0 now involves four major parts. One is data handling is one thing, one is artificial intelligence, machine learning, and IoT is also one part of industry 4.0. So where we can see here, there is a connection between consumer and producer. So using industry 4.0, there is a connection that is forming between consumer and producer. So earlier, when we want to buy a vehicle, or when we want to buy any product from industry, there won't be any connection. So simply we will go to a place where the produced goods, we go there and we examine them, and we can buy what are the available things there. So now because of industry 4.0, the production line is something like this. Based upon the taste of consumers which is sitting in house, the production starts at the tender, at the factory. So for example, if number of consumers who are liking a red color car, okay, imagine most of the people who want to buy red color car, then this data is readily available with the producers, production companies, car production companies, and they have this data, and they try to manufacture cars which are red in color. So that means what here, rather than producing different types of colors of cars, now they are able to identify what is the taste of the consumers, and they are starting the production. So it is something like this. Some industry 4.0 operated factories, there are only few industry 4.0 operated factories available in India. So out of them, it is something like this. If you click pay button here from your mobile phone, the production starts in the factory. So within minutes, you pay the amount to the factory, and the production starts at this. So what is advantage we are getting here from this? So the advantage here is, there is no wastage of resources. The consumers are always connecting to the producer, and time to market. I mean, earlier days always talk about time to market. Now time to market, and these are all these are not happening because of industry 4.0. And one main thing is IoT is one among them. So not only this aspect, even in controlling machine to machine communication, so a lot of individual machines that are available in any manufacturing unit. So because of this IoT, earlier all these modules, or all these subsystems are not integrated. So because of this IoT, they are able to connect all the modules, and they are able to increase the productivity of that particular the production and all. Okay, so these are all advantages. What is one advantage? Is improved productivity of staff and reduced human labor. This is one thing. Efficient operation management, so we can efficiently operate the management or the people there. Better use of resources and assets is one thing. So we can use the resources and assets here. That means earlier, for example, if we want to manufacture something, raw material waste is seen in each and every industry. So now, because of this interconnecting of all the modules in a industry, they are able to achieve, they are able to achieve, they are able to better use the resources and assets. So cost effective is one thing, improved work safety. So because of this IoT, we can design systems which provide safety to the humans which are working in the industries. So for example, a people who are working in a chemical factory. So chemical factory is prone to hazardous situations where some dangerous chemicals can enter into the air. So if they have devices which will alert these things, if they place some gas sensors which can alert, and these alert messages comes to the mobile phones which are almost 2 or 3 kilometers, 4 kilometers in radius. So then automatically the people can save. People can be saved from those type of situations. So this is one thing. Improved work safety is one thing, and also thorough marketing and business development is one thing. I already told you earlier. Improved customer service is one thing. Improved customer service. The companies who want to provide a connection between the production and the consuming, then obviously the customers will be retained to that company. So all these things can be achieved using IoT, especially industry 4.0 technology IoT, as well as machine learning and data science as well. Okay. Better business opportunities we can have, all these things. These are all the benefits you can see here. Use of smart devices, reduction in operational cost, enhance security measures, gathering rich data, and achieve customer centricity. So gathering rich data is one thing where we know that almost 700 billion devices are being connected to internet nowadays. By 2026, an estimation of around 700 billion devices that are able to connect to the internet. So as these many number of devices are being connected to the internet, we need to handle a bulk data. So a rich data is available, and then this part, data analytics part, comes into picture. Data analytics part comes into picture, where we have to analyze a bulk data, and we have to make use of the data, and where we will run different types of algorithms to achieve a particular task. So that's what happens in machine learning. So in machine learning is something like this. Okay. So they want to identify the industry, they want to identify the taste of consumers. So how they are going to run? So they will collect a bulk data which we knowingly or unknowingly we are leaving in the website. Okay. Or they will collect it from some surveys or opinion polls. They collect all these things, and they will come to a conclusion of a particular data. On this particular data, they will run some analytics or algorithms which will identify, so this is the best solution for the product if you want to sell it in the market. So they will come to a conclusion. So they will run different types of machine learning algorithms, and they will come to a conclusion of that. Okay. So this is like gathering rich data and using it for data analytics. Okay. And achieve customer centricity is one of the other benefit. So as we know that where there are benefits, automatically we need to address some challenges if we want to achieve those benefits. So what are the challenges of IoT? So the main challenges is as the number of devices are being double, triple, 10 times tenfold, or the devices are increasing day by day in tenfold. So obviously we need to keep track of the data that is readily available in the internet. That is one thing. And also this thing, IoT issues with security is one thing. Security is one thing. um, Lack of regulation about IoT is one thing. Challenges with compatibility is one thing, and limited bandwidth. So this is one thing. Limited bandwidth and customer expectations um, are going beyond our calculation. So these are all some challenges which should be addressable by the um, as an IoT designer. We have to address all these challenges. So out of these, security is one thing. Security is one thing which we have to consider, because see, see, everything is available in the uh, phone. So we always keep connected to the internet using the phone. So knowingly or unknowingly, we are pushing so much data onto the internet. Maybe our personal data, or maybe the data that is belong to an organization, or maybe the data which is critical to a government sector. All these data are being pushed onto the internet for a purpose. Okay, so without transferring some data, or without giving some data, we are not able to run day-to-day life. So as this is the case, security is one of the important thing where everyone has to consider. It is something like, see, if you are walking on a road, you don't know, you don't have a guarantee to come back to your house. So what is that? See, what is that if a truck comes and hit, or what if a bike comes and hit you? So you don't know. So what you have to do? I mean, security in a cyberspace is just something like walking on a road. So you don't know whether you come back to home. Okay, you don't know that. So similarly, as when you are walking on the road, you follow certain protocol, you follow certain rules and regulations to come safely back to your house. Similarly, when you are using internet of things, or when you are using internet related applications, you need to follow certain rules and regulations. Okay, see, sometimes even if you follow rules and regulations, there is no guarantee. Here also there is no guarantee for the data what you are putting it in the internet. So in that aspect, you have to consider those things, and you have to maintain proper rules and regulations for handling of internet of things, and data that is giving into the internet. Okay, so these are all some top 10 strategic IoT technologies and trends that are set here because of this IoT. One is artificial intelligence. Okay, that is one thing. Social, legal, and ethical IoT is one thing, and infonomics and data broking is one thing. So these are all different IoT technologies. Because of IoT, these technologies have been evolved, and so edge to intelligent mesh. See, it is something like this. Earlier, the computation or the processing of the data is done on the edge side, edge computing. So that is locally, that is processed uh, in a local computer, or maybe local server. Okay, because of cloud and IoT, now the data whatever you are working on is not at all computing at your location. It is maybe computing at some other place. Okay, so this is additional advantage we are getting. So because of this, we know that uh, the physical performance, or the physical need for more server based applications are not coming here. Because of cloud availability and IoT, all the data what we want to run are running in somewhere else, which creates an intelligent mesh type of computing, or which nothing but intelligent cloud type of computing. So you can see the shift from centralized and cloud to edge architectures is well underway in the IoT space. These mesh architectures will enable more flexible, intelligent, and responsive IoT systems, although often at the cost of additional complexities. Okay, so that is one thing. And IoT governance is one thing. So nowadays we can see here, some cities are being selected as smart cities. Okay, so how they achieving the smart city awards or rewards, how they are able to achieve this thing. So with the implementation of IoT, so all the for example, if you take a municipal network, so municipal corporation, so if they try to interconnect all the garbage collection trucks, and if they want to, if they run a particular data on this, something like this. See, obviously the garbage value, or the garbage amount of garbage that we are getting it from a particular area depends upon the population of that area. So even sometimes even population values also won't able to give a proper amount of garbage that is being generated from a particular area. So then what if they implement IoT? See, something like if they install some devices in the garbage collection places, and if they try to collect the amount of garbage that is in terms of weight, if they are able to calculate, then management or maintaining of that particular corporation or the cleanliness of that particular municipal corporation will be very easy. So they, if the amount, if they, so they first they try to collect the data and they will analyze the data and they will come to know that, okay, so in this particular area we are getting a weekly this much amount of garbage. Then why don't we put more number of people in that particular area to collect the garbage, or more, or they can send more number of trucks to that particular area to collect the garbage. So if they do like this, if they use the internet of things, if they use the smartness in doing the service to the people, then automatically these type of systems, these type of places will get a smart city award or something like this. So that governance is one thing, maintenance is one thing. So all these things will come to come as an additional advantages of IoT. Okay, you can see here, as IoT continues to expand, the need for governance framework that ensures appropriate behavior in the creation, storage, use, and deletion of information related to IoT projects will become increasingly important. Okay, so and also, as more number of projects or more number of applications are being evolved in IoT, so we can see more number of sensors are being manufactured. Earlier, we used to have only a few sensors which we can work on. So nowadays, as it goes on, we are able to see different types of sensors. So some sensors are gas sensors, some sensors are chemical sensors, some sensors are voice modulated sensors. I mean, they can able to identify the voice and they can give the person. I mean, the image of the person who is speaking. Okay, so like that, there are different sensors which are evolving day by day. Okay, because of this IoT expansion. This is one thing. And so you can see here, coming to the applications, that is about introduction of IoT and applications. We can see here lot number of applications, whether you take it a medical sector, whether you take it from agriculture sector, whether you take it from building spaces or industries, customer services, power distribution side, operation side, marketing side. So there are a lot of applications that we can see using IoT. Like wearables, this is one thing. So health sector now, they are using this particular IoT as one of the main thing, health sector. Okay, so this is one thing, like wearables. Okay, so you can see here, in recent times there are so many gadgets which we are using and which are connected to the internet. The most popular is a smartwatch. Okay, so smartwatch is a capable device which can monitor all the vitalities of a body. For example, they can monitor blood pressure, they can monitor oxygen in the blood, they can monitor ECG, they can monitor what else? They can monitor all the heart rate, etc., etc. They can monitor all these things. So now the future is going to be for variables only. Okay, so what is these variables? You can see for sports people, you can see in cricket they are able to identify the bat speed. They are able to identify the amount of power that is used for hitting the ball. All these things they are able to calculate. Or sometimes they're also calculating the amount of the distance covered on that particular day. So for example, if you take cricket, so in cricket, so they are installing some devices on the body. I mean, like variables, maybe they install it in the watch, or they install it in the shoes, or they install it on the neck, or what else, they install in different places, and they are identifying some vitalities, like so this person has covered this much distance, okay, in this during this time. So he is losing this many number of vitamins, minerals, and he is going to be dehydrated after this time. So if these the sports doctors or sports physicians, if they have this data, then they can condition the sports person accordingly. Okay, so they after the end of the game, end of the day, they will nurture the players by feeding more electrolytes, or they will feed the sports person with more minerals or more electrolytes, etc., etc. They can feed. So if they have this data from coming from the variables, they can able to do that. So all these things that are we achieve because of this IoT and all. Okay, so this is variables. You can see here, smart shirt, we have smart shirt, smart glasses, smart bracelet, smart finger, smart belt, etc., etc. Smart socks, okay, which can useful for the pronation. So each feet is having a different pronation. Some people have a some people have flat foot. Okay, some people have a different type of pronation. So then these things, they, if we wear a socks and if they identify, so this is the area which this person feet is continuously touching the ground, then they can avoid the injuries which are caused by the weight of their body. So all these things can be, for example, sports person, in so sports person, they often they use some the more most frequently they will prone to different types of orthopedic issues, sports issues. Okay, uh, so these sports medicine, we call the sports medicine, is uses these data coming from shoes or coming from watch, and they will analyze the each and every sportsman in a different way, and it is helpful for them not to uh, prone to the injuries which they often feel. Okay, so this is one thing. So next, smart grid is one thing. So in smart grid we have a different types of applications that we can achieve from IoT. Okay, so as we know that the generation of power is not centrally located now. So distributed generation comes into picture. Because of this distributed distribution generation, each and every corner of a place, of a location, can able to produce power, and they are able to generate connect to the grid. Okay, so as earlier we used to have only one direction of power utilization, that is from grid to the consumer. So now we don't have in that scenario where all these existing distribution network has to be changed. So because of smart grid, maybe you can go with smart metering. Okay, or it may be maybe smart way of calculating the power factor in a particular area, or smart way of identifying any losses, smart way of identifying any faults involved in a particular area. All these things are now able to achieve with the smart grid, and then they able to because of this transmit IoT technology, they can serve in a better way. Okay, so if we are able to generate power in a smart way, obviously we can uh, decrease few larger power plants. So in production point of view, we can do that. Fewer larger power plants and many smaller power producers we can go with. And the market point of view, earlier we used to have centralized and mostly national wide we have. So now it is decentralized, and we are ignoring the boundaries. Okay, so that is one thing. So on transmission side, based on large power lines and pipelines, instead of that we can go with small size because the production is small. Okay. So then we distribution side also, earlier I told you, right, only in single direction. Earlier distribution is from top to bottom. So but now as there are local generation of power from renewables, solar, wind, etc., small players also comes into picture, where they are giving power to the grid. So these both directions it is possible. And consumer point of also, earlier we have only passive, the consumers only use it to consume the power. Now the consumers are able to generate the power. So that means it is active or passive, both the consumers comes into picture, and they are participating in the system integrity. Okay, this is one thing. So this is all achieved because of application of smart grid, which uses IoT technologies. So industrial IoT, this is IoT which is coming nowadays, which because of this industry 4.0 industry IIoT is one thing that is comes into picture. They uses all these things. They uses different types of sensors, monitoring tools, automation, safety, quality, industrial applications, network centric, etc., etc. These are all the part of this industrial IoT, that is IIoT. And medicine, in medicine also we have a lot of applications we can see here. Some applications like insulin pumping, okay, so continuous glucose monitoring systems, so CGMS systems, continuous glucose monitoring systems, where because we know that in India the main concern is all the people are prone to type 2 diabetic. So what happens is that because of the food and all, this type 2 diabetes is easily affected with the people. So in that they have to monitor the glucose levels in the blood continuously. So they are able to design IoT systems which monitors the glucose levels in the body, and they are sending those values to the mobile phone to the patient as well as to the doctors. So they analyze this data. That means, for example, it is like if you eat morning time, if you eat breakfast, so how much amount of glucose that is being generated with the breakfast into the your blood. So they will monitor that. So after that you will walk for some time, or if you go for work, so they will analyze how much energy you are spending for the work. Okay, so what is the remaining amount of glucose that is available, so how much fat that is being converted. Okay, that is one thing. So after maybe in lunchtime you eat other food, and again how much amount of glucose that is being released into the blood. So they will try to analyze your blood glucose levels 24/7, and they will collect some data. They will analyze the data, and the medicine prescription will be depending upon that analyzing of the data. So this is achieved with this IoT. So this IoT, where they are able to connect the CGMS machine with your phone, and they are able to achieve the data. So after observing the patient condition for a few days, what they will do is that they will the doctors will prescribe different types of medicine depending upon your food habits, or depending upon how your body is responding. So all these things are achieved with this IoT applications in medicine, like deep brain neurostimulators. This is one thing. They are able to study, they're used for study of brain, okay, or a study of some psychotic behavior of some people. All these things they will do. Gastric simulators, foot drop implants, okay. And see, this is one thing, like implants nowadays, for every small reason people are going with implants, like knee joint replacements, etc., etc. So you don't know the behavior of that foreign element in the body. So then what is, they want to study that behavior on your body for some time. They will install some IoT devices, like wearable devices, or um, some devices which we kept, which we will they will put it in the body. They will examine that, and they will analyze how this material is behaving in our body. So they will do that. So IoT has a wide applications in medicine. Okay, so these are some consumer IoT products, like helmet concussion sensor. Okay, so which are placed in helmets in times of accidents and all. They will use medical alert watch, smart fitness clothing, and smart running shoes. Okay, so one button product purchases. Okay, so is Amazon Dash is one thing. Okay, so simply we can, if you uh, Amazon Dash or Ola Dash is one thing. One other thing, which is using IoT technologies in um, e-commerce area. So garden sensors, smart televisions, etc., etc. So smart farming is one application, uses IoT to improve agriculture and etc., etc. So so these are all something. Okay, so right. Okay, so till now we have seen what are the applications, what is IoT, what are the things that we see. Okay, what are the advanced applications in the IoT, and what are the benefits of IoT, etc., etc. So right, so if we want to build an IoT project, okay, so we need some tools in designing IoT projects, that we will see what are the things. So So the device hive is one thing. Okay, so this is an open source machine to machine communication framework, so which is intended for industry IoT applications and all. So mainly useful for security, smart home technologies, remote sensors, automation, etc., etc. This particular tool is used for creating IoT applications in these areas. So there is a cyber vision and is aimed to providing end-to-end support for connected devices across large cloud. Okay, so this is a cloud-based service. Okay, which is useful for um, middleware, IoT solutions, connected applications, and smart products. So this is Arduino. So, as a student, undergraduate student, this is a place where we start IoT projects. So we try to adopt IoT Arduino. It's a small board. So we try to adopt that Arduino, and we try to program that Arduino, and we connect that Arduino to internet, and we make that as a smart. So this is a most common platform. Okay, so which offers both hardware as well as software. So it will act like both debugger and emulator. So it is a IDE, that is integrated development environment, where we can simulate, where we can debug, as well as we can transfer the code. Emulator, it acts like an emulator. Okay, so this is home assist is one thing. Okay, and so device hub, this is one thing. Device hub is an integrated solution for IoT project development. The service combines business intelligence and cloud integration in order to sense. So here earlier, as I told you, right, edge computing is there now because of cloud computing came into picture. So in order to facilitate the cloud functionalities, we have different tools or solutions. So among them, device hub is one thing, which is an integrated solution for our IoT project development. The service combines business intelligence and cloud integration. So this is one thing. So that is about different tools that are available in creating the IoT projects. And next, so as I told you earlier, IoT is nothing but a combination of a sensor, actuator, controller. All these things connected to internet is nothing but IoT product. So we have a different types of sensors. We have different types of sensors that are connected to the to make IoT projects. So we see maybe it may be a thermistor or temperature sensor, or infrared sensor, ultrasonic sensor, gyroscope, accelerometer sensor. So all these sensors are now available, and using these sensors we can make IoT projects. So sensors is one end to the controller, and obviously we are going to have actuators on at the other end of controller. Okay, so where sensors basically give input data to the controller. That means it may be an Arduino board, or it may be any other board, and actuator is where where the controller gives output and the actuation happens. Okay. Temperature sensor, you can see this is a diagram of figure of a temperature sensor. Temperature sensors measures the amount of heat energy in a source, allowing them to detect temperature change to data, and different things. Okay, humidity of values also we can sense. So this is the thing, and the pressure sensors here. Okay, so mainly pressure sensors are useful in manufacturing water systems, as it is easy to detect fluctuations or drops in pressure. So water systems are built using these pressure sensors. Okay, proximity sensors. Proximity sensors are something like proximity sensors. There are a lot number of proximity sensors, a wide variety of proximity sensors. Say it may be infrared sensor, it may be ultrasonic sensor, capacitive sensor, magnetic sensor, etc., etc. There are different types of proximity sensor. So the main advantage of proximity sensor we can see in automation of industry. So where they want to, in manufacturing, they want to run or they want to finish the product automatically. So I mean, right from raw material to finished goods, lot number of proximity sensors are involved. Say it may be packing, say it may be pressing, say it may be mixing, okay, etc., etc. These things, these sensors come in handy in especially in industrial automation. So level sensors here. So in manufacturing or in cutting is one thing where they will try to cut metal sheets and all in manufacturing, some shapes and all. So they will see the proper level has to be there. So some proper precision has to be followed in manufacturing certain elements in industries. So the leveling is one thing. Okay, so like for example, level sensors are used to detect level of substance including liquids, powders, etc., etc. Many industries including oil manufacturing, water treatment, beverage and food manufacturers factories are use level sensor. So it is something like in Coca-Cola bottling industry, they have to see whether the liquid has poured right amount in the right bottle. So there they will use this level sensor, and if the level has reached a particular to a prescribed reference value, then they will tell that 200 ml or 300 ml or 400 ml has been poured into the bottle. So these level sensors will take, and these level sensors will give data to the controller, and automatically control will analyze that and will work on the actuator. The actuator may be a valve, so which can close or which can shut off that container, which can shut off that vessel. Okay, that these things can be done. Waste management systems provide a common use case as a level sensors can detect the level of waste in garbage garbage can or dumpsters. Okay, so these level, okay, so this is also one garbage handling also can be done with level sensors. So accelerometers, uh, so that means accelerometers, you know that it senses the objects which are being in motion. So accelerometer detects an object's acceleration, that is the rate of change of the object velocity with respect to time. Accelerometers can also detect changes of gravity. Okay, so they can also use like anti-theft protection alerting systems is one application of accelerometers. Gas sensors is there. As I told you earlier, chemical factories are installed with various gas sensors which keep on tracking the data, and so they can widely used in chemical factories and all, gas sensors. So after that we have actuators. So various actuators are there. Hydraulic actuators, okay, which is useful for heavy load applications, mainly in industry, pressing or lifting heavy weights. They use actuators which are hydraulic. And pneumatic actuators are there which work with air. So some light applications or packaging or some food safety applications where they don't want to use hydraulic, because in hydraulics they have oil is the medium. Oil is the medium in hydraulic actuators. So in the medicine and food automation industries or food packaging industries, so these hydraulics are not used, because in medicine and food packaging industries, uh, air will be used, because they don't want to pollute the manufacturing process. So that's why they use pneumatic actuators. That is one thing. And other thing is these are all low payload applications in the field of medicine or food processing industry. So that's why they will go with pneumatic actuators. Electrical actuators, we know that electrical actuators precision, where precision is needed. Okay, so here you can see here in pneumatic actuator as well as hydraulic actuators, the compression is one thing. So the medium whatever we are using, that is they are prone to compression. The air can be compressed, and the precision we are not going to achieve that precision using the pneumatic actuators as well as the hydraulic actuators. Whereas electrical actuators, we can achieve that, because there is no medium here, there is no air or there is no oil as a medium here. So obviously if you want to achieve the precision, okay, it is something like that. So in mixing two components for manufacturing of a tablet, so even 0.005% of one material should not add to the other material. So in that case, so the precision is needed. So that precision is achieved using electrical actuators. Okay, actuators here based upon the temperature changes, the actuation happens. Okay, magnetic actuators. So these are all different actuators, work on different types of principles. Okay. This is a relay actuators. So that is about introduction and applications and different types of sensors and different types of actuators that we can see in IoT applications. Okay. So now we will move on to the hands-on session where we try to do where we try to work on blink. Okay, so in the agenda we can see this. So we will work on the blink IoT 2.0 app, working with Arduino. We will see coding sample programs and we will see that part. Okay, so we'll move on to the hands-on section. See, if the participants having a node MCU with you, so it's better to connect your node MCU to the laptop. Okay, so because simultaneously you can do along with me, if you do, then it will be effective for you. Okay, so let me stop sharing this PPT and move on to the next part, that is hands-on session. Okay, let's move on to the next part. Is the screen visible to you? Hello? Hello? Hello, is the screen visible to you?
Yeah, visible, Balaji, visible.
Okay, thank you. So first we will see Blink 2.0. Okay, so this is a tool which we can operate the IoT devices from the web as well as from your phone. So this is a tool which facilitates us in controlling the devices in and also in building IoT applications. So all of you Go to Blink Cloud. Okay, see, actually I have already signed in. Okay, so the people who don't have this account, they can create account. You can click on here, create a new account, and they will ask the mail, and they will ask you to agree for certain terms and conditions, and you can sign up using your mobile phone, sorry, your mail ID. Okay, so once if you um, log in, you can able to once you sign up, you can able to log in that. You can see here, login. Okay, so here I am creating one template here. Okay, so there is a left side, we have templates. If we click on the templates, it will ask you, it will take you to this window where you can see new template. Okay, so if you click on this new template, see, the here we are trying to, in this particular first experiment, basic experiment, we are trying to control LED which is on a node MCU, that is a ESP. Okay, ESP32, or you can have a ESP8266. Okay, whatever. So there are two types here. The advanced is ESP32, and we have ESP8266 node MCU. So any one of the thing you have. So we have a inbuilt LED which is there on that node MCU. So we are writing a program, we are using Blink to control that LED from your mobile phone, or controlling that LED using web-based controlling, or mobile based controlling. So for that, what we need to do, first you have to sign up for Blink, and then you have to click on these templates. If you click on the templates, you will go to a new template. There is an option called new template. If you click on that new template, you can have here. Okay, so here I am giving what, LED control, right? So I am giving this as LED. Okay, and here I am. So what is the hardware you are using? What is the hardware you are using for this program or for this project? So there are lot number of options here. So you can have ESP8266, ESP32, Arduino, micro Arduino, Raspberry Pi. Okay, all these things that you have. So I am selecting, my device is ESP8266. So I am selecting this. Okay, so here I am connecting that device with what type of connection here we giving. So whether you are using Ethernet, or whether using Wi-Fi, or USB, or GSM. So I am choosing Wi-Fi, because the connection I want to make it using a Wi-Fi. Okay, so here description here is, this template is for controlling the LED. Controlling the LED, that means making switch, maybe making on and off of LED, controlling the LED. Okay, so that's it. You can click on done. Okay, so you'll enter into this window here. Okay, so here your template name is LED. So already we had given all these things. Okay, and you can see here. So you just click on save. Okay, so this data which we can see here, hash define Blink template ID, and hash define Blink device name LED. So this is important. This is important. Here, this with this data, we are making the communication between your LED. So here the device is LED. So as I told you, right, in IoT there is a sensor, there is an actuator, there is a device, and there is a controller. So here the device here is a LED, and we are making that LED smart, right? So in order to create that communication between the blink and the ESP8266, that is node MCU, we need this particular data, that is template ID and device name. See, this is a totally new one, that is blink 2.0 is new one. Earlier we have a blink, okay, so where we have to after creating that, some authentication tag will come to your mail. So using that authentication tag, we put it in the code and we are able to create communicate. So here no need of having authentication code, simply we need this template ID as well as the device name. So we copy these things in the code, okay. So this is one thing. And metadata here, so metadata, no need of handling all these things, no need of for this experiment, as we are not handling any sophisticated or secure data, simply we are controlling the LED, no need of having this data. And we move on to the data streams, okay. So in data streams, here we want to create the data stream. So here you can click on edit, new data stream. So now here we have to see, because here we are creating a virtual pins using blink, and these virtual pins have to be connected to the physical pins of the node MCU, because to the physical pins the LED is connected. So now we are writing the program using virtual pins, and we have to define those virtual pins. Okay, so in this there are different options here: digital pins, analog pins, virtual pins, and etc etc. So I will choose a virtual pin, and this window comes in front of you. So here I have to define the virtual pin. Okay, so what is this pin name? The pin name here, why virtual pin, let I am connecting this as LED, okay. And the pin number here, you can see here lot number of pins are there, okay. So let I am using the as a V0, and here I am getting what type of data we are getting it from that pin, okay. So as we are operating LED, so LED is going to be either on or off, okay. That means either it's going to be a 0 or 1. That means uh, it is not a float value, or it is not a double value, or it is not a string value. So I will choose that as an integer here, okay. So units here, so units you can leave it, or okay, so because we are not as it is integer value, zeros and ones, we here there are no units. For example, if you are writing a program for temperature or humidity values, here you have to give the units, because temperature is monitored in Celsius, or humidity is monitored in percentage values. So that units you have to prescribe here. So the minimum and maximum values are 0 and 1. You can see that, and you can also assign a default value. The default value is 0. So let the default value is 0, and you can create the here the virtual pin. You can create the color for the virtual pin. So let my favorite color is blue, so I choose the blue as this virtual pin color here, and I can click on create. So you can see here, okay. So I can able to create this data stream which is connected to V0 pin, and the integer value, and minimum is 0, and this thing, okay. Similarly, if you want to control one more LED, okay, I can go with one more new stream, and I can assign that to there, okay. Next, events, okay. Events, nothing events here, no need of handling, because this is not the time for discussing events, because we are dealing with only simple things. So next, web dashboard, okay. So this is a place where we will design the dashboard and controlling that LED using the web, okay. So you have left side, you have so many widgets here. You can choose any one of them, as this is a basic experiment where we are controlling the LED, okay, where you are controlling the LED. So simply switch here, I drag this from the left hand side and I put it here. Add new widget. So here widget I am adding is a switch type. So there are many number of widgets here. Label is one thing, gauge is one thing. See, for example, if you are operating on a pressure sensor, okay, so you want to control the pressure sensor from the web, or you want to control the pressure sensor from a mobile phone, then you have to use this widget. Okay, so our image if you want to see some widgets that is not that won't come for free, we have to upgrade and we have to pay for some. So and service chart, for example, if you are monitoring the temperature, irradiance value, humidity value, and what is the amount of voltage that is being generated, what is the current that is utilized, etc., etc. These are can be created using these widgets. Okay, so as this is a simple one where we are able to uh, control the switch LED here. I need only this thing. Okay, so here you can see here there is a gear symbol. If you put the cursor on this, you can see the gear symbol. So we can also increase the size of widget here. We can able to or we can place anywhere in this area. Okay, so we can there is an option called here, you can see the gear symbol here. If you click on this, it will ask, okay, what is this switch for? So what is this switch for? So this switch is for what? So this is LED control, right? LED. Okay, so what is the data stream you want to use? Because you already given the data stream, you already created the data stream. So you have created that to a virtual port. This LED should be connected to a what virtual port? V0. Okay, so here it is showing, right? So LED and so on value is 1, off value is 0. Okay, show on and off. Okay, so this is on. Okay, while operating that, if you press that LED, you can on, it shows the on label and off label. Right now the condition, now the LED is in um, off case. So if you make that on, it will display as on. You can see here the label name we are able to change while operating the LED. It is automatically changed. Okay, so this is one thing. Or I mean label position, it should be left or right. Okay, you can do whatever you want. So this thing or that thing. Okay, so this thing. Okay, so you can do that. On value is 1, off value is 0, on label, off label. Okay, and you click on save. Okay, so this is being created. Okay, so this is being created, you can see here. And next is a mobile dash. That means as how we created web dashboard. So this is a dashboard, you created a web dashboard. See, for designing web dashboard, you need a data stream, you need information of the device name, you need mostly you need these two things, data stream as well as information. Okay, so for creating the widgets. Okay, right. Next, similarly you can you should also I mean the controlling of that LED, either you can open a browser and you can able to control that LED, that is one thing, or using mobile phone also you can able to control. So for that, what you have to do is that you have to download a Blink app. You have to download the Blink app. So either if you are using an Android phone, go to a Play Store. Okay, and click download the Blink app. Okay, so Blink app. So earlier we have a Blink app. So um, um, yeah, Blink. Now it is changed to Blink IoT app. Okay, so download that one, new app one. 1 second. So if you are Apple user, go to App Store and search Blink. Okay, so let me show you that. me take this to okay, where is this? Yeah. See, are you able to see phone here? Hello?
Yeah, proceed.
Sir. Okay, yeah. So, in this, if you go to App Store, okay, so if you click on Blink, you have so many Blink applications here. So go to Blink IoT New. Is the screen visible to you?
Yes, sir, visible.
Are you able to read that? One second. Yeah, I think now you can see Blink IoT New. Okay. So you download this one from the App Store, and if you open, I mean, after downloading, so you will get this one. Okay. So here also the same thing. The logging is same thing, the same ID how you created web, the same thing you use user Gmail as a user ID, and the password you created in the earlier web case. So you log in this app. Okay. And next we'll come back to this one. Okay, so we'll do that part later. We'll do that part later, and next we move on to the coding part. Okay, so under this Blink here, Blink web portal here, so you can able to do two things. One is creating that template, okay, and creating the data streams, and creating the web dashboard. Three parts you have done. So creating the template, you are creating LED template, you have created data streams, your LED is connected to a virtual pin here, V0 pin, and the values you had given in the data stream, and you created what? Web design. You have created a web dashboard where you created you dragged one widget, and you named that widget as LED, and you have made that widget here. So next we move on to the coding part. The coding part we will do using Arduino. One second. I think you are not able to see this. I should share. Oh, sorry, there is some connectivity issue here. I came out of thing. Let me share this one now. Okay, so the blink part is over. So we move on to the coding part. So you have to install this IDE, that is Arduino IDE. So I already installed Arduino IDE here. So you click on this Arduino IDE. Yeah. So this is the thing here. Students, so this is a place where we will write the coding part. See, as I am using ESP8266, okay. So you need to first see whether the libraries are there for ESP8286 as well as the libraries are installed for Blink. Okay, because you are controlling the LED using Blink, so you have to make sure that whether the library files are there for Blink as well as ESP8266. So if you want to see them, you have to go here, sketch. Under sketch you have include library. Under include library, okay, you can see here there is a Blink. So that means I already installed the Blink library files, as well as ESP8266. The library files related to ESP8266 also should be there. So if we don't have, see, while you are initializing Arduino, sometimes you don't have these library files included. So then what you have to do is that you have to download it from the internet, have the internet download those files, and you have an option called upload. Okay, upload here. So you can upload them, or you can see here there is option called manage libraries. Okay, so if you click on that manage libraries, hello, one second, I think because of too many applications it is. Let me switch off this one for a while. Yeah, see, if you click on this, you can see here, you just, oh, 1 second. It's taking some time. So under tools you have manage libraries. If you click on that, it will open. I mean, the system is busy. Yeah, see here the downloading libraries is happening. We will wait for 2 minutes.
హలో డాక్టర్, ఎక్కడున్నారు? పులిపూసలా ఇంట్లో ఉండే వంగాలు తాగుతున్నాడులే. సరే, మన ఇంట్లో వంగాలు ఉన్నాయంటగా, తాగమంది డాక్టర్.
Hello. Yeah. See, we have to check whether the proper libraries are there or not. Okay. See, you are using ESP, right? ESP 8266, and you are using a Blink. So you have to check like this: ESP 8266. Yeah. See, if you click on this, you'll get plenty of library files, and you have to see the relevant libraries for your board, and you have to click on that, and you have to install that. So now I want to install that Blink related library files, BLYNK Blink. Okay, so I will see whether it was installed or not. Yeah, Blink. See, Blink already I have installed this one. You can see the latest version will be installed. Okay, so if you did not install, it will show you that it will prompt you to install that library files. So as I already installed this Blink related library files, it is showing that installed, and the version is 1.01. That is the latest version. So this is the thing you have to done before going the program. Okay, so then I have to open a space for writing the program. So for that, no need of writing the program here. I already have that format. For that, what I have to do is that go to examples. Okay, under examples, if you go down, okay, so you'll get examples related to Blink. Okay, so you can see here. So Blink is already installed, right? That's why you got these examples related to Blink. And if you go to this, you have a Blink agent. So under Blink agent, you have different types of Node MCUs, different Blink related programs for Node MCU. So what is a Node MCU you used here? You used ESP8266. That's why you have to go to this place. Okay, and open the second. Okay, okay, so file examples. So already Blink program is there here. Yes, sorry, Blink, and Blink agent and ESP26. Okay, so this is the thing. So this is already predefined here. So the logic what I want to write here is, So you can see here first one, template ID it is asking, and it is asking Blink device name. So where we are going to get these things? We are going to get it from Blink console. Okay, so we already created a Blink template here in the Blink console. So here you can see here. So here go to the info. Under info you can see here hash define Blink template ID and hash define Blink device name. So you copy these two from here and paste here. So you paste here. You take off these things and you paste here. So automatically you got the Blink template as well as Blink device name here. Okay. So next the program. Let me type the program. So I already typed the program for the Blink here. Okay, let me copy this one and Control V. So here the simple program here. So no need to worry here. So you know that I already explained the template ID and device name. We are getting it from Blink console where we created that, and here it is showing the Blink firmware version as 0.10. So it is already given by this example here. Hash define Blink print serial here, and you can see here, and this is the logic here. So this is all functions. Using functions we write the Arduino programming here. So Blink right here we are making use of the virtual pin. So we already defined the virtual pin in the Blink here. So that virtual pin where we connected LED here earlier, we connected to V0. So that we are making use of that, and we are calling that virtual pin. And if that virtual pin is having a value high, okay, so that means if we press that virtual pin using a web or using mobile phone, you are creating high value or you are creating a low value. So that high value or low value you are writing physically on a pin of node MCU. So here the LED, the inbuilt LED of node MCU is connected to a GPIO pin 2. So that's why what you are doing, whatever the value you are getting, whatever the value from virtual pin we are getting, you are assigning to a variable called param dot asint. Okay, this should be capital. Okay, so you are assigning that parameter or the value of virtual pin to this value to this variable, that is a parameter as integer is a variable here, you are assigning that, and if that value is 1, then you are writing pin 2 as a value high. High means it will make that LED on. So or else if it is not, if the virtual value is not 1, then you are writing a pin 2 as a low. So that you are doing that, and you are calling a function to connect the Blink connect. Okay, and you are synchronizing the virtual to digital pins, physical pins to virtual pins, you are synchronizing that. So in order to do that, you have to write this thing. So these are all already existing, these are all existing functions, you have to make use of them. Okay, so in setup what you are doing, you are setting the pin 2 of node MCU as output, and you are you are setting the baud rate of serial communication between node MCU and your Blink. So the baud rate should be what 115200 is the baud rate you have to set. So this is a Blink agent. This is the beginning the function, and this is a loop where you have to run the existing function. So this is a simple program. So the logic is this only, this part only. If the virtual value is 1, it should be high. Virtual value is 0, it should be low. Okay, so why you are getting virtual values? That means we are getting virtual values from the widget what we have created, because we have to control it from the web or we are to control it from the mobile app. So after that, what you have to see is that you have to see whether your Arduino is connected or not. Okay, so let me switch on this one. Where is this? LV. Yeah, autofocus. Okay, so you have to connect your node MCU to the laptop. So once if you connect the node MCU to your laptop, once you connect, 1 second. Yeah, I think it's visible now. So once you connect your node MCU to the laptop, you have to make sure one thing here. So you have to go to the Arduino and you have to go to tools again, and you have to see whether you have connected to proper serial port or not. Okay, so my node MCU is connected to communication 3 port, and you have to make sure whether the port is connected properly or not. Sometimes you may connect different types of node MCUs or different types of board to the laptop. So you need to make sure in order to send the code that is present in Arduino IDE to the board, you have to first create the communication properly. So that you have to see this. Okay, and next you can see here board MCU. See, a board also should be there. So if your board is not, just like library manager, you have to see whether your board is there in the IDE or not. So I already have this ESP286. So in board manager, if you click board manager, you will have different types of boards, and you can click the type of board whatever you want, and you can add them to the IDE. Okay, so my board is already connected. That is a node. Oh, sorry. So my board is already connected here. Slow, 1 second. Yeah, so my board is already connected here. Board is a ESP12V module, that is ESP8266. There are different types of ESP8266 are there. So but you have to connect the ESP12V module node MCU 1.0. So you have to make sure you have to select the proper board. So that means two things you have to see. One is the communication, whether proper port is assigned or not, and a proper board is given to the IDE or not. So after that, simple thing. Okay, so we have to click on this upload. If you click on uploading, it it will write the program. It takes some 1 or 2 minutes to write the program. Okay, it is taking some time. You can see here. So hotspot. Okay. Oh, it's taking much time, I think, because of so many applications. Yeah, you can see here it is writing the program, and it is 19%, 23%, 28%, and you can see here it is showing uploading. Okay, uploading, it is showing uploading. Once if it is 100% uploaded, it shows done uploading. So now you can see here, while writing the program, the LED goes off, and now it's a blinking. You can see the blink. That means the code is done. Okay. So, okay, done uploading. The program is now uploaded to the board. Okay. So we will see whether is properly connected or not. So for that, what you have to do is that you go to here tools, and there is a serial monitor here. Okay, serial monitor. Okay, so it is not showing anything here. Okay, so what you have to do is that there is so there is a pin here, reset pin. If you press reset pin here, you can see on the serial monitor, you can get the values here. So now here my ESP board is connected to the laptop, and it is linked with the program whatever I have created. So but it is showing here, okay, it is waiting. Okay, sorry, I think you already connected to this one earlier while testing process. It is already connected to one Wi-Fi. So if I want to remove the Wi-Fi, okay, if I want to remove that Wi-Fi connections and new Wi-Fi connections, then what I have to do is that I have to press here. There is a boot button here. If you press that boot button for 10 seconds, the old Wi-Fi settings which are configured earlier will be erased. Okay, so just wait for 10 seconds. You can see there now the message is hold the button for 10 seconds. So if I press it for 10 seconds and leave that, okay, so now the old Wi-Fi, you can see here earlier the Wi-Fi settings are Redmi Note 7 here. Now we can configure new Wi-Fi. We can connect Node MCU to new Wi-Fi connection. Okay, so you can do that in that way. Okay, so now we will go to the Blink app. Okay, we can go to the Blink app, and where we will configure the mobile dashboard as well as we can control this thing. Okay, so let me go to the. Is my mobile visible to you? Hello? Yeah. Okay. So you go to this, and you can see here I have you go to the add new device. Okay, add a new device. You click on add new device. Okay, so let me take off this. Yeah, connecting. So once you installed the app, okay, you'll have the screen like this. Okay, you log in using the same credentials. Login. Okay, and you can log in that, and you can get this Blink node MCU. Okay, so you can see here there is LED here. Already we created whatever we created in already we created in the web console. We got here. So you click on this, and you can create here. The template comes like this. I think, is it visible, guys? Okay, so you click on plus here, and it is asking for the buttons here. Okay, so main widget here. Okay, so the button you select here button as LED, and if you click on this, it will ask. Okay, it is asking title is LED. Okay, and it is asking select data stream here. So already data stream switch here, and data stream is selected, and like that we will run this thing. Okay, so 1 second. Okay, actually I have to save this thing. You can delete one because it is not asking for. Okay, okay, so here you can see add new device. Okay, so this screen will come. Okay, so under add device, because I have to connect the device, the node MCU, to the mobile phone here. So connect to Wi-Fi. Okay, so it is asking ready, check your device. Okay, so I already connected device, so ready. So it is asking to, so you can see here Blink wants to join Wi-Fi network, Blink LED 57417. Okay, so it is asking, okay, join, and it will search the nearby Wi-Fi network, near hotspots or not. Hotspot. So it is showing the different hotspots available here. Okay, so that is MI11. Okay, so So I'm checking this, and okay, so I have given the password. Okay, and you can see here continue here, and now the device is configuring. Okay, configuring Wi-Fi, waiting for the device, and final check. These are the three options that has to be ticked here. So first option is over, configuration of Wi-Fi is over, and waiting for the device here, waiting for the device. So waiting for the device to get connected. Yes, it is connected. Now you can see here blink LED 57417 is connected now. Okay, it is shown, it is connected, the device, the node MCU is connected to the blink here. So now continue. Okay, so blink LED 57417 is ready to use. Okay, so click on done. Okay, and exit to app. Okay, so now you can see here. So the now LED is there here now, LED. Okay, so I already created that here, LED. So you can see here LED, and if I press this, okay, so you can see here LED, and now I have to select the data stream here. Okay, so LED button is already there, and I have to choose the data stream because I already created data stream where that virtual to the data will come to the virtual port. So select the data stream. Under that we can see here already the created data stream. You select that. Okay, you want push type or switch type? I want switch type. On and off labels. Okay, on and off labels, and text color. Okay, whatever the text color you want, I want red color. Okay, so close this. Okay, and title alignment here. Okay, so everything is okay. You close this. Okay, and you can see here LED here V0 assigned to V0, and if I press this, okay, sorry, close this, and you can see here. So you can see here the LED goes off. Okay, LED goes off this. Okay, so if I press from the mobile phone here, okay, so mobile phone, so mobile phone is here. Oh, I think it's not. The mobile phone is here and node MCU is here. Okay, so if I want to make that on, so you can see click on, you can see the LED which was there on node MCU is on. So if I want to make it, see, if you have mobile phone with you, okay, you can control that LED anywhere in the world. So that's what IoT, right? You are assigned just one pin to one LED. Similarly, you can assign all the lights in your house to different pins of this node MCU, and you can able to control that and you can able to control that using your mobile phone. So you can see here I can make that off. So now node MCU pin LED is off. If I want to make it on, I am operating it from the mobile phone. So I am operating it from mobile phone. Okay, you can see here, and I can make it on and I can make it off. See, the same thing you can do it for n number of lights that are there uh, in your house. Okay, and you can control them. Say it may be like how I created one pin. Okay, one light, and I assigned to one pin. I have taken one virtual pin and I assigned one light to that virtual pin, and I am able to control that LED. Similarly, in the house, if you have 10 bulbs, you can assign those 10 bulbs to 10 virtual pins, and you can see the status of your bulbs in your house anywhere, sitting anywhere in the world. You can see whether your bedroom light is on or off, whether your backyard light is on and off, everything you can see that, and you can able to control that. You can make it on and off if you have one node MCU with you, which connects, if you connect all these things to this. Okay, so this is one thing, this is one experiment. Okay, Similarly, we can able to track the temperature and humidity values here. Okay, so for that you need to have this first schematic diagram. Are you able to see the schematic diagram? So this is a schematic diagram for monitoring the temperature and humidity values from the DHT11 sensor. Okay, so here you can see here this is the connection where we are connecting your laptop to this USB micro USB, and which is connected to the node MCU. Okay, this part, this connection, and at the output end of the node MCU, you are connecting the RGB LEDs. Okay, two RGB LEDs. One RGB LED you are connected to temperature values, and another RGB LED you connected to monitor humidity values. See, the temperature value you are setting it from 0 to 50 degrees. Based upon the temperature values, this RGB will glow in a different color. For suppose if it is 0 to 20 degrees Celsius, it will glow in blue. You can assign that. Okay, RGB, right? You can show blue color. If it is if it is 20 to 40, you can show it as in green color. You can show it as in red color if it is above 50 degrees Celsius. Similarly, the humidity, based upon the different levels of humidity values, you can show different RGB colors in the RGB LEDs. Okay, so you have, for this you need a temperature sensor here, and the number for temperature sensor is DHT11. Okay, so this DHT11 is having 3 pins predominantly. One is ground, one is data, and another is supply pin, VCC. Okay, so to the VCC, you will connect the VCC pin to 3 volts pin of node MCU. I have two 3 volts pins in node MCU. Okay, so to one 3 volts pin I connect VCC, and ground is connected to ground, and the data is connected to D5. That means I am sending data from the D5 data output pin. I connected to data pin of DHT11. Okay, so see this sensor. Okay, this sensor, whatever the value that is there, that data value is transferred to the D5, because this DHT level sensor, it is a combination of transducer and some microcontroller unit present in that DHT level. So this microcontroller unit, what it will do is that it will sense the value from the transducer, and it will give a digital value to the D5 sensor, D5 pin of node MCU, and node MCU will be controlled, because node MCU is a Wi-Fi module. We can control that node MCU, and we can able to see the data that is given from the DHT level. So this is the physical connections what I am showing here, and this is breadboard connections what I already done here. Okay, and you can see here the program part. Again, the same thing, you have to go to Blink console here. You have to go to Blink console. So you have to go to Blink console. Okay, so you have two devices here. So because as this is a basic version, it will allow only two devices. Let me disconnect this one. So delete. I am deleting this device. Okay, and let me connect this one and connect one more node MCU to the laptop. Okay, so I have connected the this DHT11 sensor and node MCU. Okay, and you can see this to the laptop. The same thing we have to go. Okay, similar way. See again here you have to go back to. So you can go back to new template. You can go back to new template. So here it is asking temperature sensor, right? Temp. I am writing the name of the template as temperature, and I am writing it for ESP286, and the connection type is Wi-Fi, and the description is this template will monitor temperature and humidity values. Temperature and humidity values. I am doing that, and you click on done. Okay, so it creates a new template here. The same thing. See again, you are getting a different template ID for every template ID. You are getting a different template ID, and a device name. You are naming the device name. Temp, I had given temp. So these two are important in coding because we have to assign these as a library file. So you have to give these template ID and device name to the program. So if you won't give that, your Blink app is not able to connect it to the node MCU. Okay, so this is a unique code that is being generated by the Blink. Okay, so you can do that. You can see here will monitor this thing, and metadata here. Save. You click on save. Okay, you click on metadata. So metadata is not needed here. Okay, so data streams here. So data streams here. I am creating a data stream, new data stream here. Okay, so what are the things here? Again, analog here. Okay, so the field name is temperature. Okay, and I am assigning okay, so one second. Okay, cancel. See, you click on a new data stream and you click on virtual pin, because I have clicked just now analog pin. You click on virtual pin. So you assign that virtual pins some temperature. Okay, and virtual pins are something like this. V0. Okay, so V0 and integer value I am going to get, because I am going using DHT11. I am going to get temperature values that are with a 1 degree Celsius gap. So all obviously the value I am going to get as a integer. Okay, so let me assign it as V1. So V1. What else? Units is what here now? Celsius. Okay, Celsius. You have to give that. And here you can see here minimum value and maximum value. Minimum value is this, and maximum value I can assign as a 50. Okay, and default value is 0. Okay, and you can select any one of these. Okay, let me select the blue. Okay, temperature. Okay, okay, and this is okay, and this create. You click on create. Okay, so next again new data stream, because one more data value you have to handle, right? So that is for humidity. Humidity. And you assign that for V1 is already used, V2. Okay, so this is also integer, and units are percentage, and minimum value is 0 and maximum value is 100%. So default value is 0, and this is this thing create. Okay, so like that you have these different values. You can see that, and you can go to the next one, like a web dashboard. Okay, so in web dashboard you can see here similar to earlier case, you simply switch, you drag this switch button and you put it in a widget and you go to settings. Okay, switch here is a temperature, and data stream is V1, and choose on value, and this is off value. Okay, show labels here. Okay, labels here on and off, and you are going to get these things. Okay, so you are going to get the same thing as I told you earlier. The same things you are going to get here, and you are able to do that. And you click on, where is this? Temperature on, off. Okay, so you can set that, set whatever you want, and you can click on this one. Where is this? What happened? Yeah, 1 second, sir. I think some connectivity issue. Oh. Okay. So you can see here, already created here. So dashboard here, you can see here temperature. You can it is able to read out the temperature values here and humidity values. Similar way, you can able to read it from the mobile dashboard. The mobile dashboard is same thing. Okay, just like how we are done, the same thing you can. The programming part here, the same thing you have to go. You have to go new. Okay, file open examples. You have to go to the Blink and Blink here and ESP286, and you have to write the program. So I already written the program here, and Control A, Control C, and I am pasting it in the, so you can see here these two. Before this I need to give what, the unique template ID and this thing. Okay, so how I'm going to get, you go to info, you copy these things, Control C, and you paste it here. So this automatically connect this thing to this one. Okay, so everything is over, and we have to see whether it is connected or not. So I have connected. Okay, board is connected. Okay, and it is connected to communication port. Okay, so let us dump this program. So it takes some time. So the logic here is simple. Here it is taking RGB values and it is outputting those values to the RGBs. And here I have set 3 different categories. If the temperature is greater than 0 and less than 15 degrees Celsius, okay, your B1 value, B1 is a value. B1 is nothing but RGB. B value is B. You are initializing a virtual value for B1 and you are writing the value to that one. So and next, simply if T1 is greater than 14 and less than 30, it will giving a value to G1. Okay, so R1, G1, B1 is for temperature sensor for holding temperature values. R2, B2 and G2 are for humidity values. See, humidity value is low, that means B2 will be the done. Okay, so and now the program is being writing to Arduino board here. The program is being writing. After it completely writes the program, the LED will switch it on. Now it is in blinking state where the program is done uploading. So we have to see that communication port. Where is the communication port? Yeah, serial monitor. Sorry, serial monitor, and you have click on the reset button here. So if you click on the reset button, okay, it is now we have to link the internet to the IoT. Okay, so again the linking how you have to do? Go to the mobile app. Go to the mobile app. Go to the mobile app. Log in. Okay, log in using your credentials. Log in, and you click on add a new device here. Add a new device. So connect to Wi-Fi. Okay, make sure that you have given power to the node MCU, and here it will ask, okay, are the devices ready? Okay, you click on ready. Okay, it is okay. Blink wants to join Wi-Fi network DHT11. Okay, so join. So Wi-Fi is prompting us to join a Wi-Fi connection, and it is checking the Wi-Fi connections, nearby Wi-Fi connections. So now again I am connecting to the hotspot here, and I am connecting. Okay, I connected here, and continue. Click on continue. So again the configuration is done. You can see here in the serial port. In the serial port, the values are being generating. So configuring Wi-Fi. So now it is prompting a message. Okay, so connecting to Blink. Yeah, so it is showing, right? So it is showing fail to read from DHT sensor, very hot humidity. Okay, so now continue. You click on continue. Okay, done. Okay, exit to app. Okay, so okay, it is showing, right? So then you come back, you come outside. Okay, and click on this one. Click on this one. You have to add the buttons. Okay, so adding the buttons here, you are not adding the buttons. You want the values. Okay, that if you see that here. Okay, so you can see here these values you can get it, and you are going to get different values here. So this is going to be something like this. So you are going to get the value something like this. Okay, like that you can able to control the or get the data from the ODMCU using this. So here I am stopping because time is not permitting to deliver all the experiments. Sir, are you available, sir? Rajendra sir?
Yes, sir. Yes, sir.
Ravindra sir? Yes, sir, I'm available, sir.
Sir, thank you very much, sir.
So, thank you, sir.
Sir, thank you very much for a clear-cut explanation about the IoT and its implementation by considering different examples, practically shown the results, which helpful for us very well. Rajendra sir, please unmute all the participants. Participants, if you have any doubt, please ask the resource person directly. If anybody have any questions, or otherwise, we move forward for the valedictory section. We have a small valedictory. So, on behalf of the Bapatla Engineering College, myself, Dr. J. Ravindra, and Mr. K. Rajendra, coordinators of this event, we thank you very much, President of Bapatla Educational Society, Sri Uppalayan Srinivasara Garu, and Secretary Sri Manav Nageswara Garu, and other dignitaries, respected governing body members, and the principal Dr. V. Damodar Naidu Garu, and HOD Dr. G. Ravikumar Garu, and senior professor Dr. N. Ramadev Garu, and other faculty members. Thank you very much for giving your valuable support for this occasion. As on the HTTP program, okay, we got 483 registration, 383 registrations for this HTTP, and in this show, 125 members are our Bapatla Engineering College students, and more than 150 faculty members are registered, and they are actively participated throughout the 6 days in this HTTP. And the remaining around 125 to 150 students from other colleges also joined, and they got benefited. So, regarding this, once again, I thank you very much for all the faculty members in the Department of EEE for giving their valuable support to conducting in this HTTP in a smooth manner without having any disturbances or any issues. For smooth conducting, you are supported very well. It's very appreciable from all the faculty of the EEE department, teaching and non-teaching members of the EEE department, Bapatla Engineering College, Bapatla. So now I am hand over the session to Dr. N. Ramesh Garu, Associate Professor in the Department of EEE, Bapatla Engineering, Bapatla, to say the vote of thanks and for further process. Sir, Dr. N. K. Ramesh Garu, please continue, sir.
Thank you, Dr. J. Ravindra. So, respected dignitaries, my colleagues and participants, a very good evening, one and all. It's my privilege to propose vote of thanks on this occasion. First of all, I am very much thankful to the management for their constant support and encouragement to conduct this kind of events in the department. I would like to thank our beloved principal, Dr. V. Damodar Naidu, for giving permission to organize this event. I would like to thank our resource person, Dr. G. Ravikumar, Dr. N. Ramadevi, Dr. N. Karthik, Dr. K. Kamala Devi, Dr. P. Sampath Kumar, Dr. J. Parthasarathi, Dr. J. Ravindra, and Mr. N. Balakrishna for enlightening us with their knowledge. The 1 week short-term training program is full of knowledge and interesting things. It gave deep insights into the relevant topics and revealed many interesting facts. Once again, I would like to thank the resource person for taking out time and enlightening us with the knowledge. I sincerely thank the convener of the event, Dr. G. Ravikumar, head of the department, who is a source of inspiration and motivating among the students because of his vast knowledge and acumen in the subject. I would like to thank the co-conveners of this event, Dr. J. Ravindra and Mr. K. Rajendra, for their enthusiasm and commitment in making this event a grand success. I also extend thanks to all staff members for their enormous cooperation in making this event a grand success. Last but not the least, I want to thank the student volunteers who really worked hard to make this event successful. Also, I thank all the participants for paying attention and learning. Thank you, let us close the program by national anthem.
Rajendra, sir.
Thank you, one and all. You may discuss now. With this, we are concluding the program.
Sir, one small announcement, sir. We are not going to conduct any exam for this STTP, and we are going to issue certificates based upon their participation and the feedback form submitted by the for the all the 6 days. Okay, so with this information, we will end the session. Once again, thank you very much for all. Thank you, one and all.
Thank you, sir.